And I'll just make it a little clearer. It's going to go blurry. Okay. In the previous class, we drew two scatter plots for the Rogers and Lang methods of dog training. In addition, we calculated R. What is R a measurement of? Linear correlation, or how closely points fall on a line. How closely the points fall on a line. The scatter plots for the Rogers method and Lang system are shown below. The Rogers method has a strong one, so this one's close to R, but if you notice, the R we calculated was this. The Lang system has a weak R, and the R we calculated was this, negative. So they're saying the Rogers method has a positive slope. Because R is negative, we know it has a negative slope. But R does not tell you what the slope is. Today we will perform a regression analysis. All that means is we are going to use a formula, an analytical technique to determine the relationship. In other words, we're going to find the equation of a line. We want the equation of, the lines of best fit, the equations of a line. That's all we want, is the equations. That's all we're trying to do. The regression line is a straight line that describes how a dependent, remember, dependent always goes here, independent goes here. And you would think that the score depends on the hours of training. Once we have an equation, we can use the equation to predict values of y for any value of x. Now, when we have a bunch of points and we want to find the equation of the line, the symbol for the slope is A. That's our slope, and that's our y-intercept. A is the change in y when x increases by 1. Or the slope, rise over 1, right? A is rise over run, just like you learned before. This is the y-intercept, B, of a regression line, is the predicted y value when x equals 0. This is only a good prediction if your x values or your independent variable can take on values as 0. They call this a least squares regression line, and it minimizes the sum of the residual squared. Minimizes the sum of the residual squared, and I'll explain that in a residual squared. Well, what does that mean? If we have a scatter plot and we have a line and our points are there and there and there and there, the distance between the point and the line is the residual. That's the residual. This difference is the residual. This difference is the residual. The residual equals y value of the observed point minus the y value of your equation. Okay? So the y value, it's the difference. This is your residual. The y value of your observed point minus the y value of your equation. Similarly here, y value of your observed point, when you subtract it, in this case you're going to get a negative residual, but we're squaring it so we do not lose that important data. So what we were doing, using these equations on the next page, we're actually going to be just doing a regression analysis, okay? And these equations minimize the residuals. Just because you have a strong R, do not assume you have cause and effect. Why is that? Why can we not assume there's cause and effect when we have a strong R? Right.
Things that we cannot actually see, like obviously control it,
Yeah.
we cannot define a correlation between X and Y.
Perfect. Beware of extraneous variables. That's why. Unless you're in a laboratory where everything's controlled, the temperature's controlled, everything is controlled, there's most likely extraneous variables. Yes? Could be. I would need more specifics. I don't have any proof of. So what are you asking? Sorry, I don't have an answer for that question. I've never heard of anything like that, so I'm not sure. Okay. Yeah. This one? Sorry? Shh. I know it's a hot day. We've been suffering in this room. Is that okay? Can I explain anything better? So if you were to look at this equation, it's very similar and compare it to the R. That's the R equation, right? If you were to compare it, once you got the R down, a lot of people, when they do these calculations on a test, they forget the N. Don't forget the N, okay? But do you notice that this, if you know this and this, you can get your equation here. Notice the similarity. And B, the y-intercept equals the mean of your observed values subtract A times the mean of your observed X values. So we calculated all of this. We did it yesterday. So now let's do the equation. So A equals, how many points did we have yesterday? 9? I agree. 9, sum of xy minus sum of x minus sum of y all over 9 times sum of x squared minus sum of x all squared. Crazy, eh? I didn't quite write this right, so I'm just going to fix it right now. So this will equal 912 divided by 962, and that is approximately 0.9480. That's our slope. For every 1 it goes to the right, it goes up 0.9480. Now B is the mean of our y values, so it's sum of our y values divided by 9, minus A, which is 9. I'm keeping accuracy here, that's why I'm using my original numbers. Sum of x is 91 over 9, or the mean of x is that. And when you, this is just number crunching, you'll have your calculator, is about 3.0811. Y, here's our equation now. Y equals A, which is, if we put it to 4 decimal places, 0.9480x plus 3 points. And that's just an equation of a line. That's what you're used to, mx plus b. So I don't know what else I can tell you. Just learn the formula and get some practice plugging in the numbers. It's just number crunching, right? I'm going to let you, well, why don't we do it together? We might as well. We have time. We calculated, let's do it for the Lang system. Our R value, notice the R value in the slope. The R, do you remember the R value was 0.9611? Here the slope, it's different. Notice how different the slope is. The sign of the slope is the same, but the value is different. It's close. Let's do the equation of the Lang method. So it's going to be 9 times sum of xy minus sum of x times sum of y all over 9 times sum of x squared, 1027, minus sum of x all squared. Well, that should be 1047, right? When you work that out, you get negative 150 over 774, and that is about, I'll write it down here just to save some space, negative 0.1938. Let's calculate B. The mean of the y values is 86 over 9 minus negative 150 over 774 times the mean value of the x's, which is 93 over 9. And if you work that out, you get approximately 11.5581. So your equation becomes y equals negative 0.1938x plus 11.5581. Just to compare the R value with the slope, R was negative. Was negative 0.2243. Like they're close. They have the same sign, they're close, but they're different. Well, what do we do with these equations? Well, we can predict. We can interpolate or we can extrapolate. If we extrapolate, we use x values between our data range, like we use x values from 5 to 16. This is when we interpolate. Now, when we go outside our data range, it's called extrapolate. And any value above 16 would be extrapolation. So, if I wanted an x value of 10, would that be extrapolation or interpolation? And if I do an x value of 2, that's extrapolation. Let's use the Rogers method because it has a better R, so we can predict. Y equals 0.9480 times 2 plus 3.0811. We get about 4.9771. We just use the equation to predict. So, a dog with 2 hours of training would get a test score of 5, about 5, right? It's just a prediction. We'll just say of about 5, just so. Now, if we interpolate, so we're using a y value of 9, get I have the cow. It's approximately 12. So a dog with 9 hours of training would get a test score of about 12. Makes sense? It's just a matter of memorizing them. Start memorizing them now. The way I memorize is I write out each equation 20 times to make sure I have it. Because I don't memorize well. Any questions? Can I explain anything better?
For link system in this case, can we interpolate or extrapolate any data, although it has a really weak correlation between the two?
It does